Hello. I think I'm audible. So I will start today's lecture. Am I audible? A very warm good evening. We will start today's session. I hope that I'm audible and my screen is visible. So I will share my presentation. Till now we are at the theory and methods for environmental valuation, right? So we will move forward. Last session's lecture in fast pace, and then we will discuss the week 9 lecture series in this session, and we will also discuss the question answer of week 9, including the quiz and practice questions. So in the last session, we started the economic valuation of environmental goods and services. So we asked the question that why there is requirement of valuation, right? So there is requirement of valuation because the environment is utilized inefficiently and the extraction of resources from environment is inefficient. Why? Because there is improper valuation of environmental goods and services. There is no proper market, and there because of which there is overutilization of resources happens, right? So to give value to the environmental goods and services, we are learning the various approaches to to calculate the economic value of a certain goods and services from environment. So, in this, we say that since there is no direct market to the environment, it is difficult to give the value to the environment, right? So, therefore, there is for proper valuation of environmental goods and services, we are learning various techniques uh, to estimate the value of economic value of environment. So we have differentiated various types of economic value. It can be differentiated into use value, non-use value, and option value. Use value are those value from environment which we directly or indirectly consumes. Indirect use value, we can say that the environmental goods or service is consumed directly, or it from the aesthetic beauty of environment you are getting certain satisfaction. So that is the services which directly enter into your utility function. So in the uh, indirect use value, we can say that though you are directly not getting satisfaction from the certain environmental goods, it is providing indirectly certain help such as flood preventions or prevention of soil erosions and etc. So, such services which are not directly entering into the utility function but indirectly helping us in certain way can be termed as indirect. And then the existence value, which is from the mere existence of certain environment, we are getting satisfaction, because of which we are getting certain utility. So this is known as existence value. Bequest value is the satisfaction which you get out of thinking that your future generation will be benefit out of it. And then in option value, you are keeping option open for your future use. So these are various economic value which you can give to environmental goods and services. Then we have learned about various valuation approaches. So what are different methods of giving value to the environmental goods and services? So there are three main methods. Uh, First one is stated preference approach, second one is revealed preference approach, and third one is production function approach. So in a stated preference approach, there are two subcategories, which is contingent valuation method and choice experiments. And in revealed preference approach, it is divided into hedonic pricing and travel cost method, right? So till now, we have already covered the contingent valuation method. So in contingent valuation method, or in overall in stated preference approach, what we do is that we create a hypothetical market for environmental goods and services, and then we ask various respondents to state their preferences for possible change in environmental quality. So the change in environmental quality can be positive or negative. So for a positive change in environmental quality, what is the respondent's willingness to pay is noted. Similarly, for a negative change in environmental quality, what is the willingness to accept this degradation of environment quality is noted. So in this approach, there is stating or quoting of willingness to pay or willingness to accept without actual payment. So this method is therefore known as stated preference approach. Now, in revealed preference approach, the preference of uh, environment are already revealed by consumers. So why it is done? Either it is done through hedonic pricing or travel cost method. So in hedonic pricing, the preference of environment is revealed through related market, such as a housing market. So let's say that there is apartment of specific attributes. One is in a green area and one is in a polluted area. So for the same attributes, uh, for the house having same attributes, the pricing of house in the green area is much higher than the price of house at the polluted area. So this additional money a consumer is willing to pay for cleaner environment is revealing the value of environment. So indirectly from housing market, you are deriving the value of greeneries or value of clean environment. So this is one of the method. And in travel cost method, what we do is uh, the consumers travel for different places to enjoy the nature, to enjoy the aesthetic beauty of the environment. So the from the money spent to enjoy the nature or uh, enjoy the clean environment, to travel to those places, we are trying to derive the preference of environment, from which we derive the value of environment. So in the stated preference approach, contingent valuation method, in this, what we do is we define a utility function, which is function of alpha and gamma, where alpha is environmental quality and gamma is composite good. So, with change in the environmental quality, either the betterment of environmental quality or degradation, what is the consumer's willingness to pay or willingness to accept is noted, from which we try to derive the total value curve. So this total value curve is derived from change in environmental quality from alpha 0 to alpha 1, and degradation in environmental quality from alpha 0 to alpha 1 prime. So this value of gamma 1 and gamma 1 prime indirectly gives the willingness to pay, which is gamma 1, for better environmental quality from alpha 0 to alpha 1, and willingness to accept for degradation in environment from alpha 0 to alpha 1 prime. So we can see that willingness to accept is much higher than willingness to pay. And economic value of environment is always estimated for a change in environmental quality. So for a change in environmental quality from alpha 0 to alpha 1, we are trying to get the economic value of that environment. So this is the overall objective of CVM. So the steps in CVM involves, first we will try to set up a market for environment, and then we ask the respondent to participate. We define the quality of goods, we define the price, we define the change in utility, we tell them how the payment is done, how the pricing is there, and from there we note the willingness to pay and willingness to accept of each of the participants. Then uh, willingness to this obtaining bid can be either close-ended or it can be open-ended referendum. And then after that, we are estimating the mean WTP and aggregated WTP. So this is the overall method of CVM. So in close-ended referendum, what we do is we define that for environmental change from alpha 0 to alpha 1, what will be the what will be the amount which you are willing to pay, that is, let's say A1. So for additional water, like for a certain amount of additional water, are you willing to pay 100 rupees per month or not? So the response can be either yes or no. So in close-ended referendum, the AI is specified, and AI is decided using certain prior meeting group discussions for understanding the location, for understanding the economic background of that location, and certain pricing. Then we try to define the minimum, maximum, and average WTP. Uh, then AI is set randomly, and we ask different respondent, different AI, and AI, let's say that AI is set in such a way that the minimum bid amount is accepted by all respondent and maximum bid is rejected by all, and there are two bids around the average. So from here, let's say that we note the response, that is gamma, a 1, 1, 0 for no, and 1. So for certain AI, what is my gamma? So we note the gamma versus AI. So the limitation in close-ended referendum is that uh, let's say that we have set up the maximum AI as 100. However, there can be certain people who are willing to pay 150 or 200 also for cleaner water or for additional water. So this is not observed in this kind of method. So therefore, it is known as partial observability problem. So consumer would have been willing to pay higher than the maximum WTP, so therefore will not be able to estimate the maximum WTP in this kind of approach. So this is on the close-ended referendum. So from let's say that this is my utility function of alpha and gamma, and UI can be, let's say, defined as VI and EI. EI is my random error, and expectation of EI is 0, and VI is defined as alpha plus beta times gamma I, and for certain amount AI, let's say that amount asked to pay for a change in environmental quality from alpha 0 to alpha 1, what will be my response function? For if you have to pay AI to improve the environmental quality from alpha 0 to alpha 1, are you willing to pay this much amount? The response will be 1 or 0, that is yes or no. Then we find the probability that the response will be 1. So through probabilistic model, we try to find the probability that the respondent will say 1. So let's say that uh, so the consumer will say 1 only if its utility from U0 to U1 have to either improve or have to be same, right? So we say that this is my U1 after payment of AI amount, and this is my U0 initial utility function. So U0 is defined as alpha 0 plus beta times gamma 0 plus epsilon 0. And U1 is that the additional payment of A1 is subtracted from the good composite or income factor. Then that should be either more or equal to the U0, right? So from here, what we have derived is theta, which is equal to alpha 1 minus alpha 0 minus beta times AI, and we are subtracting both this value beta times yi, so we get the random variable function in the right hand side. So for this probabilistic function, we are using the logistic distribution, which can be defined as pi is equals to 1 by 1 plus e to the power minus theta plus beta ai. So from here, we are deriving the odd ratio, which is equal to e to the power theta minus beta ai. And if you do log natural log on both the side, you get this function. And we try to find the value of theta and beta by regressing Ri on Ai. So when you do the regression logit function, logit model, then you get the value of theta and beta. So from let's say that Pi is equals to probability that the response will be 1, which can be defined in the logistic distribution function, that will be 1 upon 1 plus e to the power minus theta plus beta times ai, and this whole function is written as b times x, where b is the vector of coefficient and x is the vector of explanatory variables. So this explanatory variable is not only the ai term, that is money, which additional money which you are going to pay. Also it can be age, or it can be income, or it can be any other factors. So therefore the explanatory variable is also a vector of different certain coefficients, so a vector of certain variables, and b term is vector of coefficients. So Bx is defined as B0 plus B1 x1 B2 x2 plus uh, adding on to Bk xk, where k is the number of variables, right? So if you exclude the B1 x1 and add the other terms, you get the grand mean minus beta times x, where beta is my coefficient of price and x is the x is the dependent variable ai, right? So we get the coefficient of price. So uh, now we by regressing we will try to find the alpha hat and beta hat. So this is how the contingent valuation method works, right? And here let's say that pi is equals to 1, and pi probability will be between pi is equals to 0 or 1, and the logistic function is as shown here. It will be downward sloping. Initially, let's say if the price or bid is lesser, the probability of saying yes is more, and when the price increases, the probability of saying yes decreases. So okay, so till now if you have any question, then I would Love to answer that, or else I will continue with the presentation. Any question in between? Okay, so I will move to the one question which is in the quiz. So here, let's say that the analysis of environmental impact of Elva Dam and their effect on fisheries is rather extensive. A record of decision was issued on early 1996, and second environmental impact statement was issued on uh, 1996 in 1996 describing the method of dam removal. It is necessary to estimate the individual's willingness to pay to remove the dams under CVM. The variables, namely price, importance of fishery to respondents, the importance of electricity to the respondent, and the importance of the tribe to the respondent are selected. The descriptive statistics of this number of variables, where n is equals to 959 observations of this state treatment group, are shown below. Now, what we have to do is we have to calculate the grand mean, which we have already discussed for now. So, are you able to answer this question or not? So, what will be the answer? Okay, what will be the answer if anyone wants to and like wants to solve this? How will we calculate the grand mean of this question, which is shown here? Sorry. So how will you calculate the grand mean? Anyone who would like to try or tell me the answer? How you come to the answer as 0.93697? So in this, the probability function is given, and what we have to do is we have to find the grand mean, and so that is it. So grand mean, as we have discussed here, is the is b0 plus b2 x2 plus b3 x3 and so on and so forth, taking out the b1 x1. So that is how the grand mean alpha is calculated. So from here, what we can do is that, let's say that alpha will be equal to b0 plus b1, sorry, b2 x2 plus so on plus bk xk, right? So in our question, what we are given is that we are given the B0, which is minus 3.649355. B1 is given, but B1 is not included in the grand total. B2, B3, and B4. Uh, So what we get is that we have to multiply the average. Like when we have to multiply price, fishery import, importance of electricity, importance of tribe. What we have to take is we have to take the mean of each of the variable. So what we are doing here is, if you have any question, then you can ask me. Otherwise, I'll. So what we do is, here we get minus 3.649355 9355 minus 0.01 times 0.0169, sorry, minus plus 1.577091 times 3.36 1, let's say, plus fishery import and then importance, and then we have minus 0.70674 times 2.625 plus we will do 0.568792 times 2.00435. So if you multiply and add all these factors, then you will get the value as 0.936966. If you round off, then you will get 0.93697. So this is how you will calculate the grand total when the probability function is given in the form of logistic distribution, and the mean of variable other than price is given as mean, right? So when you multiply the mean with the beta coefficient and then you add up, then you will get the grand mean. So any question on this, then you can ask. Any question? Hello, am I audible? Hello, hello. Sir, am I audible?
Okay, madam, you are audible. Please go ahead, madam.
Yes. So now we will move to the next part. Now this is how the CVM works, right? So in contingent valuation method, what we get is that expected WTP, which ranges from minus infinity to plus infinity. However, expected WTP cannot be non-negative. Therefore, we calculate the conditional mean WTP, where we give the condition that WTP is more than 0. Right. So from here we try to find the expected conditional mean of expected WTP, and median of WTP, which are all function of alpha and beta. And alpha and beta are calculated while using logit model. And the logit model is solved using maximum likelihood estimator, MLE. And now when we have to calculate the aggregated WTP, then we have to multiply n, which is the number of um, uh, total number of people, let's say that, multiply times the expected value of WTP, conditional mean value of WTP. So from here, what we are getting is we are getting mean WTP, conditional mean WTP, and aggregated WTP. So this is all. Now I will skip the qualitative response model for now, as I'll come at the end, and I'll move towards the next part, which is open-ended referendum. So in close-ended referendum, what we do is we have set up the maximum value, and then we say that AI is set up as, let's say, 100. Then we ask yi, which can be either equal to 0 or it can be equal to 1, right? So this is close-ended referendum. In open-ended and the problem with the close-ended referendum is that the partial observability problem is there, where we are not able to define the maximum WTP, as a person might be willing to pay more than the maximum which we have assumed. So now in open-ended referendum, what we do is we set up, let's say, certain AI, that is payment which one have to do, which is equal to 100. Are you willing to pay? Yes, we increase it. Are you willing to pay? Yes, yes. And then if they say no, then we will get the AI which is equal to 200. Let's say when we move from 200 to 250, the response is no, so we get AI is equals to 200. Now, let's say that now in this case we are noting both the willingness to accept as well as willingness to pay. So by changing the willingness to accept, which is compensation for the environmental degradation, and willingness to pay, which a a person have to pay for the better environmental quality. So these are both noted by changing the price from first value to the second value to the third value, and then we get the certain AI value in the open-ended referendum. So now, in open-ended, the problem of partial observability is solved. However, we still have hypothetical bias in this method, because here also we are assuming certain market, right? From a certain market, we are assuming AI, which will be the price of enhancing the environmental quality from alpha 0 to alpha 1, or compensation which we have to give for certain environmental degradation. So this hypothetical market, if it's not done efficiently, then we will still have the issue of hypothetical bias. So creating hypothetical market leads to hypothetical bias, which is common for CVM, either it is open-ended or close-ended. Then we move towards the strategic bias. So strategic bias means that since this CVM method does not involve actual payment, so the respondents may respond strategically, either because of warm glow effect, or to impress the interviewer that the respondent is very environmental conscious, or they are very much educated, or they are what like they are conscious of clean environment. So to impress the interviewer, they will try to overbid. So this overbid is done, which is known as warm glow effect. So even if I say that, are you willing to pay 200 rupees per month for extra water, they're like yes. 300 rupees, yes. So this kind of overbidding is done by the respondent, might be done by the respondent. And in the second one, the free riding problem. So let's say that I'm a respondent, then they are saying that I'll have to pay 100 rupees for additional water. Then the respondent may think that actual imposition of regulation and policy might done, because of which I will have to pay. So to enjoy the free riding and not do the actual payment, the respondent will again respond strategically, and they will try to underbid. So this underbid and overbidding might cancel each other. However, we cannot uh, ignore the issue because of strategic bias. So these are two issues. Now, embeddedness or embedding effect, or bias. So, how it is done? Let's say that uh, there is. I ask the respondent that you have to pay 100 rupees to protect one wetland. They are like, okay, I'm willing to pay. Then, if we say that we are protecting four wetland, are you willing to pay 400 rupees? So, if calculation wise, it should be yes. However, the for wetland the response is only 160 rupees or something, not till 400. So there is indifference, there is very insignificant difference in WTP value for protecting one wetland to the four wetland. So what we are saying is that uh, there is smaller or bigger, there is not much bigger change in the willingness to pay of consumer. So in this case, the more is better principle does not work, and the utility function are uh, so uh, normally what we do is in utility function, the preferences of consumer is noted in such a way that the more is better principle is assumed, right? So more is the chocolate and biscuits, more will be your utility. More is the wetland protection, more will be your utility. So that does not follow in here. So we can say that this utility function which you are assume is based on more is better principle. However, in actual it's not being followed. Therefore, we cannot rely much on the willingness to pay which you obtain from open-ended referendum. So it is also called part-hole bias. Why? Because let's say that we ask the individual that we are protecting a tree or certain trees, what is your willingness to pay? And we ask, we are protecting the whole biodiversity. What is your willingness to pay? So there is very less difference between these two scenarios, scenario one and scenario two. So they for protecting a part of the biodiversity or the whole biodiversity, there is not much difference in the willingness to pay of the respondent. So therefore, it is known as part-hole bias. So overall, this issue is not known as embeddedness. So I would like to stop here and ask if there is any question in between. Any question? So even now we are at contingent valuation method only. So the in the bidding process we have open-ended and close-ended referendum. So we are now discussing the limitations of open-ended referendum. So we have discussed the first is hypothetical bias, second is strategic bias, third is embeddedness. So and then now we will try to. Okay, so is there any question? Then please mute. You can unmute yourself or you can ask in the chat box, and I will move forward with the presentation. So, okay, now initially when we say that the willingness to pay and willingness to accept curve, right? So we try to draw a alpha versus gamma curve where this is my willingness to pay and this is my willingness to accept. Let's say that the magnitude of alpha 1 and alpha 1 prime are same. However, for the same environmental quality change, the willingness to accept is much more than willingness to pay. Okay, so this is my willingness to pay and this is my willingness to accept. Okay, so uh, why it is so? So it is uh, first shown by the indifference curve. So the indifference curve, let's say that we are giving by Q versus Y, where Q is my environmental quality and Y or gamma is the income effect. Okay. So let's say that IC0 and IC1 are indifference curve first and second. Across the indifference curve, my utility does not change. However, if I go from IC0 to IC1, my utility value increases, right? So now let's say that for an environmental change of delta Q from A to B, for an environmental quality change from delta Q from Q0 to Q1, that is delta Q, what will be the maximum willingness to pay, right? So even though there is, let's say that if I'm paying, the maximum expectation will be that my utility will not change, right? My utility U0 and U1 will be same. So initially this is my U0. So after coming here also, my U1, U0 and U1 should be same. So the maximum willingness to pay is given by B and D curve. Okay, so first we will move from A to B and then B to D. So this BD give me the maximum willingness to pay. Okay, so for a environmental quality change from Q0 to Q1. Now, what will be the maximum willingness to accept? In this case, what we do is we move from B to A, right? Initially, IC1 will be my first utility and then IC2 will be my second utility. Sorry, IC0 will be my second utility, that is at A. Now at A, I will draw the perpendicular line to the IC1. So this C point is the point where the uh, intersection of this perpendicular line with the indifference curve happens. So to make the U0 is equals to U1 condition, the maximum willingness to accept. So willingness to accept is given as AC. So when we draw the DD and AC, we can see that since the indifference curve are convex in nature, the AC is much higher than BD. So from the curve, from the shape of indifference curve, we can see that the willingness to accept is much higher than willingness to pay. So willingness to accept is shown by this and willingness to pay is shown by this. Okay. So if you have any question, then maybe I can ask. You can interrupt in between. Okay. Now, what are the reasons behind the huge disparity in willingness to pay and willingness to accept? So the first reason we have already discussed, that is indirectly known as diminishing marginal utility. Okay, so here when we find the slope, when we find the slope of indifference curve, let's say delta y by delta q, then we get marginal rate of substitution, right? So, in when the curve is convex in nature, the marginal rate of substitution is not constant, right? So, if you move from point D towards downward, then the marginal utility get reduced. So, the marginal rate of substitution becomes higher and higher. So, what we can say is that the uh, y and q are not perfect substitute of each other, because of which we get the indifference curve which is convex in nature, and from here we can describe that the uh, because of diminishing marginal utility, uh, the willingness to pay and willingness to accept is having higher disparity, right? So we assume the standard utility function or standard preference, which is downward sloping and convex in origin. Indifference curve is the combination of two goods, which are environmental quality and composite income, and uh, it gives the individual same amount of utility of satisfaction. So for all points on one indifference curve, the utility will be same. So this is the change in environmental quality, which is beta Q. So we would say that what will be the willingness to pay, which is AC, and for the environmental change from Q2 to Q0 to Q1, which leads to utility U0 to U1. So from here we say that the um, willingness to pay is much more than willingness to accept is much more than the willingness to pay, right? Now, difference in difference curve, sorry, as I explained, it is because of the shape, and slope of indifference curves gives us the marginal rate of substitution between Q and Y. Since the indifference curve is convex to the origin, MRS is not constant, and MRS is getting higher if you go down to the indifference curve. Initially, for additional unit of Q, individual would like to pay more amount, but at Q, as Q increases, Q means environmental quality, then the individual would like to pay less and less for the additional improvement in environmental quality. So, therefore, the saturation is obtained, then the diminishing marginal return is there after certain level of Q which is being achieved. So let's assume a case when the indifference curve is constant. So the slope of indifference curve is constant. Then here in this case AC is equals to BD. Then in this case, then there is no difference between WTP and WTA. But in actual, we have this kind of indifference curve where which is convex to the origin. Therefore, AC is much more than BD. So this is how we have explained through first reason, that is diminishing marginal utility. So they are not perfect substitution of each other, environmental quality and income, and therefore there is the disparity between the WTP and WTA. Okay. Now, second one is income effect. So, income effect is that, let's say that willingness to pay is subject to individual's income, but willingness to accept is not subject to income. So, there is no limit to willingness to accept, but willingness to pay, because willingness to accept is not subjected to income, and willingness to pay is subjected to income. So therefore we can say that they everyone wants as much as they get and as much as they can get. However, because of which we can say that willingness to accept is more than willingness to pay, right? So even though income effect explain a portion of disparity between WTP and WTA, it cannot explain fully. So now we will move towards one of the principle which is known as prospect theory, given by Daniel Kahneman. The prospect theory is based on loss aversion. Okay, loss aversion means the risk aversion of any person is asymmetric. So what we are saying is that when an individual is subject to potential gain or potential loss, their risk aversion is different. So in the context of potential gain, when a person is having a risky choice and there is potential gain, then individuals are subject to uh, become risk averse. Okay. And on the other hand, when the individual are subjected to potential loss, they become risk lover. This is the first case and this is the second case. So for certain risky choice, when there is potential gain, then the individual becomes risk averse, and when there is potential losses, then the individual becomes the risk lover. So this asymmetric behavior for potential gain and loss, because the gain and loss are valued differently. So potential gain and potential loss are valued differently by an individual. So this theory uh, indirectly says that, let's say that there is a potential gain from risky choice, then the individual are risk averse and they prefer a solution that leads to lower expected utility but higher certainty equivalence. So this will be convex value function. However, let's say that there is potential loss from a risky choice. Then individual becomes risk lover and they prefer the solution that leads to lower expected utility as long as they cover the loss which is which they are facing, right? So in this case we get concave, sorry. So in the first case it is concave, and in the second case it is convex. So risk loving and risk aversion. So in this case this is concave value function, and in this case this is convex value function. Okay, and so in short, what we are saying is that individual derives less amount of utility for a potential gain as compared to dissatisfaction when the individual is having some loss. So if you have a risky choice, if there is a certain risk in taking, if there is very big risk in taking a choice, then if there is gain, you get certain satisfaction, or your utility improves. However, if you lose, then there is dissatisfaction, right? So this satisfaction and dissatisfaction for a specific amount of gain or loss are not equal. So the dissatisfaction is much higher than the satisfaction, which implies that it is more painful uh, for the loss rather than the gain which you are having, because of which you get the joy, right? So the pain is much higher than the joy which you are getting. So this theory explains that, let's say that from here, if there is improvement in the environmental quality, then this value is concave value, which is risk aversion. And if from here, if the environmental quality decreases, then it is convex value function. So this is risk loving. So your utility function reduces in the uh, convex value, and then your utility function improves in the concave value, right? So the delta U minus and delta U plus. This is my plus and this is my minus. So delta U minus is much more than delta U plus. So what we are saying is that dissatisfaction when environmental quality deteriorates, or negative change in environmental quality leads to much higher dissatisfaction when environmental quality degrades from, let's say that, alpha 0 to alpha 1 prime. Then you get the dissatisfaction, let's say delta U minus, and there is improvement in the environmental quality, which is from alpha 0 to alpha 1, and you get the delta U plus. So this delta U minus is much more than delta U plus. So this potential gain from the better environmental quality is lesser than the dissatisfaction which a person will have because of the potential loss. Why this is so? Because let's say that you are already enjoying certain environmental quality, and the environmental quality degrades from Q1 to Q0, let's say, then this compensation which you are asking, that is delta U minus, is much higher as compared to, let's say that you have already deteriorated environment, and you are moving towards the Q1, in which you are getting certain uh, increase in your utility, right? So that is uh, that is explained through risk aversion. So uh, any question, then I would love to answer that. Is there any question? You can ask in the chat box also, if I uh, or you can put your hands up, then I'll let you speak. So now we are explaining that why the willingness to pay is much higher than the willingness to accept is much higher than the willingness to pay. So the first explanation was diminishing marginal utility. With increase in environmental quality, the marginal utility um, increment is not much. Therefore, after a certain limit, there is saturation, because of which the marginal utility reduces. So the willingness to pay reduces, right? So this is one of the explanation. And the second explanation is income effect. So willingness to pay is subject to income and willingness to accept is not subject to income. So therefore, we can say that a person will say higher willingness to accept. However, the willingness to pay will be stated based on their income. So therefore, willingness to accept is higher than the willingness to pay. And in the prospect theory, what we are saying is that when the environmental quality improves from Q1 to Q0, the mm, change in utility, let's say delta U plus, and there is degradation in environment from Q1 to Q0, then we get the negative utility, right? Delta U minus. So for the individual will ask for higher compensation when the environmental quality degrades compared to their willingness to pay for the better environmental quality. So this is explained through risk aversion, which states that it is more painful for a loss rather than the joy of gain. So the pain of loss is much higher than the joy of gain. Therefore, the willingness to pay is lesser than the willingness to accept. So this is the effect. So now, why individual gets more pain for losing something compared to joy of getting something? So what is the explanation behind this theory which we have proposed, right? So this is explained through endowment effect. So let's say that if an individual already have or enjoy certain goods and services, and if and then they would always like to retain them rather than express their interest in getting the same commodity or service from somewhere else. So what we are saying is that the individual tries to retain what they have right now rather than acquiring the same goods or services from some other places or somewhere else. So, individual prefers to retain the goods and services which is already there with in their possession rather than getting the same goods and services from somewhere else. So, other than rather than getting or acquiring a goods, they will look they will keep whatever they have right now. So that is known as endowment effect. So those which are already with you are more valuable compared to what you will acquire from somewhere else. So in environmental terms, what we can say is that when I already have been enjoying certain environmental quality, and then uh, uh, the environmental quality is degrading, then the compensation which I will ask will be more, because there is negative change, right? As compared to positive change in the environment, which is Q0 to Q1. So that this is the explanation that uh, you are already enjoying good environmental quality, and then you have to move towards the deterioration. So you will try to state more compensation because you are already enjoying the goods, right? So that is why the endowment effect is there. Now, the last explanation for uh, the difference between magnitude of WTP and WTA, which is very high, is explained by transaction cost. So let's say that you have to pay and you have to uh, get the compensation. There are two cases, right? So when you have to pay, the payment is easier. However, when you have to get the money from someone, then you will always think that it involves certain time, certain money, certain paperworks are needed. So for the amount of time, energy, the individual will try to ask for higher compensation in the willingness to accept case. So since getting compensation for willingness to accept, uh, this requires the transaction cost in the form of paperwork, in the form of time which you have to give, or in the form of travel which you have to do to certain offices. Then individuals' times and energy are also consumed. Therefore, they prefer higher willingness to accept compared to willingness to pay to compensate for the transaction process. So certain difference is because of the cost involved in the transaction. So that is why willingness to pay might be 3.5 times higher than the willingness to accept. Sorry, it is opposite. Willingness to accept is 3.5 higher than the willingness to pay, or willingness to accept is might be 61 times higher than the willingness to pay. So this is the explanations that why the willingness to pay in the contingent valuation method is always higher than the willingness to accept. So any questions? We have tried to learn the reasons behind the huge difference in the willingness to pay and willingness to accept for the same change in environmental quality. So environmental amount of environmental quality change is same in the positive or negative direction. However, the money which is being asked is different. So this is majorly because of income. However, it can be explained through transaction cost, or it can be also explained through endowment effect, right? So now we will move towards the choice experiment, which is another approach for environmental valuation. Okay, now in choice experiment, what is the basis or what is the basic idea? The basis is the characteristics theory of value. So this particular theory says that the value of product or the value of service is sum of value of its different attributes. So this is the characteristics theory of value. So let's say that there is a car. So a car is nothing but it is a summation of different attributes it have. Its engine quality, its engine mileage, or horsepower, and then the size of car, and then the color, and then the gear, and then gear, whether it is automatic or manual, and then does it have automatic control, or does it have better music system, so on and so forth. So the car is having certain attributes because of which the value is uh, defined, right? The value of car is defined by its various value, including their size, color, engine, and then various control system involved, and then the gear system and various other maybe the protective system, and then the uh, whether it is robust in the case of accidents, and so on and so forth. So these are included. So what we are saying is that let's say that n is number of attributes, and uh, I is this in this case. Let's say that I is not individual. Let's say I is index, right? So then total value of certain goods is given by sum from 1 to n vi. Okay. So individual value, if you add together, then you get the total value of certain goods or services. So that is basic of characteristic theory of value. Now, let's say that random utility function or random utility model. So initially, the random utility model is used to find the total uh, approximate willingness to pay of a product. So what they do is that for each of the attributes, like for different attributes, what the like what the examiner do is they collect the willingness to pay for different attributes. Then From the willingness to pay for particular attributes, it is possible to estimate the total willingness to pay for the product. So what we do is we define the attributes of different attributes of a product, and then we ask for additional, let's say for additional music system in the car, what will be what is their willingness to pay for a better color, for a better control during the accident or anything, what will be your willingness to pay. So for different attributes, the willingness to pay of a consumer is noted, and based on it, the total willingness to pay for the product is defined. So this is known as random utility model. Now, a random utility model can be applied to any goods or services. Later on, this framework is used in the valuation of environmental goods and services through choice experiment. So, what we do in choice experiment, we define the attributes of the environment, and then we try to try to make the scenario, and then we say are you willing to pay this much, or are you choosing this scenario over this scenario. So the choice between one scenarios are given based on the specification of its attributes. So let's take an example of a wetland. So the wetland characteristics which we define are area of wetland, and then water which is used from wetland for irrigation, number of species which is protected because of this wetland, and then number of job created because of agriculture activities, and then the price, right? So now let's say that the first we will define the status quo scenario. Okay, so in the status quo scenario, the area is 40 hectare. The water used for irrigation is 200 liter. Number of species protected is 10. And then number of job created in the agriculture due to the job created due to agriculture activities is 50. And then the price is 100. Okay. Now we will define a scenario in which the area is increased from 40 hectare to 60 hectare. Okay. Now the let's say that the water for irrigation is reduced. Water used for irrigation is reduced to 150. Then our job created will be reduced from 50 to 40. However, the number of species which will be protected will be improved. Why? Because the more water are there in the overall environment, right? Biodiversity. So now for additional 10 hectare, the increase in the price is 100 to 150. Okay, now in the second scenario, the area is 50 hectare. However, we get the more water which is drawn out of the wetland, and because of which more jobs are being created. However, since water is more, the species protected is higher compared to G, however lower compared to H scenario. So that is 15, and then the price is 200. So here what we give is we give the trade-off between various attributes, right? So in the first the price is 100, and in the second scenario you have to move towards 150 for additional 10 species of biodiversity which is being protected. However, you are losing 50 liter of water. And in the third scenario, let's say, then the price is increasing from compared to a status quo scenario to 100, right? So the increment in price is 100. The number of job created in the agriculture sector is increasing, as well as the number of species protected is also increases. However, you have to pay higher price. So now what the respondent will react will be dependent on the trade-off between the price, between the species which is being protected, between various attributes. So they will think in their mind whether scenario 1 or 2 or 3 is better in their mind, that maybe I don't have much money to give, like let's say I don't have 100 rupees to pay, but I can go up to 150 to protect the 10 more species, then maybe I'll choose H scenario. Or if I'm more environmental conscious and my income effect is also better, then I will choose the K scenario, right? So this is how the uh, trade-off between different attributes is being done. Let's say that more area means more number of species protected, more water for irrigation means less number of species protected. However, more employment is being generated, less water for irrigation, more number of species protected, and less employment. So these are various trade-off between the attributes, and based on it, so the choice is done based on the utility or preferences of the respondent, and they will select option K or H or G depending on which option generates more utility to the respondent, right? So now what we will try to draw here is, okay, so what we will try to draw here is that so what we will do is that we will find the probability of selecting a particular option. Let's say that probability of selecting option G over option H, right? It can be explained. Option G will be selected over the option H only when the utility of the individual I in the option G is higher than the utility of individual I in the option H, right? For or H not equal to G. So H and G are various scenarios. You compare scenario 1 to 2, 1 to 3, so on and so forth. And then you will choose scenario 1 over scenario 2, let's say, only if you get better utility in the scenario 1 over scenario 2, right? And the utility function is given by Uij is equals to Vij, which is function of Xij, plus Eij, which is error term. So Vij is given by beta times Xij, and Eij is my error function. Then we can write from here that Vig minus Vih is more than Eih minus Eig. So this is the probability case which we get. So we say that probability that the individual will choose option G over option H is given by this probability function. Okay, so now what we do is we are here, right? So Vig plus Eig is more than or equal to Vih plus Eih. Then we get Vig minus Vih is more than Eih minus Eig. So we try to uh, give the logistic function which will be equal to exponential of mu times Vig upon sigma over the j exponential of e to the power mu times Vij. So this is the function which is the function for logit conditional logit model, where mu is my scale parameter, okay, and mu is my scale parameter. Okay, now let's say that CVI, let's say compensating demand of ith individual for the product. So the ith individual will choose the product will be dependent on beta m 1 by beta m times Vi0 minus Vi1, where beta m is given as marginal utility of money, which is uh, which is derived from the logit model, conditional logit model, and beta c is defined as coefficient of any attributes. Let's say that from attributes 1 to certain attributes, what will be the coefficient. So this is my beta c, and willingness to pay is given by minus time beta c upon beta m. So that is the coefficient of attributes to the marginal utility of, like, change in the money that they have to pay for the certain attributes which respondent prefer. So that will be given as willingness to pay. So here we have, as we had said, that the error term, like, we assume that error term are dependent, are independent and identically distributed, or it is having the well-built distribution, or it is having well-built distribution or logistic distribution. So based on the distribution of error term, we are applying the conditional logic model, which from which we derive that the probability function is equals to exponential of mu times vig upon sum of exponential, right? So from here, what we achieve is we achieve the beta coefficients. So from beta coefficients, we calculate the willingness to pay. So now let's say that there are different methodology for choice experiment in the logistic model also. The either the data can be choice specific data, where individual characteristics, individual information is constant, or individual information does not vary. So this is first kind of data, in which is known as choice specific data, which is that from attributes 1 to 2 the data will change. However, the individual specific data are not included, right? So then in the multinomial logic model, what we do is, it is chooser specific data. Here, to select the scenario 1 or 2 or 3, it is purely dependent on the individuals, uh, based on its age, income, or education level, gender, so on and so forth. So if the chooser specific data is only given, then we will apply multinomial logic model, and if only choice specific data is given, then we will apply conditional logic model. And if both the data varies through the choice as well as through the user, through the respondent, then we will collect whole data of individual as well as the choice specific data, based on which we find the value of beta and beta of each of the choice, beta c, and then we will try to we will try to find the willingness to pay. So based on this, we are giving valuation to the environment. So any question on the choice experiment part, then you can ask me. Any question? Okay. Then I will move forward. So what we do in the choice experiment is that, okay, I'll go through one more time. So in choice experiment, first we will define the attributes of a product. Then we will sum up to find the total value. So in choice experiment method, the value of wetland is given based on different values given to the attributes, based on which the individual will prefer one scenario over the another scenario. So the data of individual choosing scenario 1 over scenario 2 or scenario 2 over scenario 3 is noted, Based on this, we apply the logistic model, and then we find the value of coefficients, which will further give us the value of environmental uh, economic value of environment. So this is all. So now we will compare the choice experiment method versus the contingent valuation method. Advantages of choice experiment over the contingent valuation method. Okay. In this method, the severity of hypothetical bias is much lower compared to contingent valuation method. Why? Because in contingent valuation method, the hypothetical market is set up arbitrarily. However, here we have a status quo situation which is defined for the respondent. So the respondent will respond compared to the status quo situation. So status quo situation is based on the information of existing products, and then other scenarios are based on the improvement on the status quo situation. So by looking at the status quo situation and then the scenarios, the market, the hypothetical market is much better compared to CVM method, in which there is no the hypothetical market is more prone to hypothetical bias. Why? Because the assumption of AI to the respondent is given. However, many a times they are not able to imagine properly, based on which the biasness come. So, the second one, in this method, we can overcome the strategic bias such as warm glow effect and free riding problem. So, in contingent valuation method, we have seen that there is issue such as warm glow effect, free riding issues, right? So, in here, in there is choice of scenario one over scenario two, two over three, but there is no quotation of bit. So, since it does not give the freedom to quote the bid, the strategic bias is not there in the choice experiment method. So, we can say that the choice experiment method is better than the contingent valuation method. So, this is the overall some advantages. However, there are a few disadvantages of choice experiment method. The biggest disadvantage is that there is a requirement of optimality in terms of number of attributes. So when the number of attributes is very high, then the respondent will not able to make the trade-offs. So when you give too many options, then individual will go for heuristic. So they will not properly think, because the rationality is bound, and individual will not able to process the information properly. So in this case, when information is too much, then we get the heuristic response, and uh, too less of attributes is also not preferable, because then the good or service is not properly defined. So uh, when there is too much, then confusion to the respondent, and when there is too less, then the good is not properly defined. So these are both not desirable in the case of contingent valuation method. Okay, so mm, so we are left with a few more slides. Maybe we can do some questions first, or if you have any question, then you can ask me in between. Okay, maybe we will. Okay, I hope that you have already solved this, but we will try to solve a few of the questions here. Yes. Now, if you are there, then I would like to get the responses in the chat box. So we will try to solve the practice question of week 9. So the first question says that the expected value of willingness to pay or mean willingness to pay ranges between. So the solution will be, so you can just type the answer in the chat box. It might be right or wrong. You can say A, B, C, and D. So what this is trying to ask is that the willingness to pay or mean value of willingness to pay ranges from. Mm, okay, so as we have discussed before, the expected value of willingness to pay ranges from minus infinity to infinity. So we have saw in the last slides that so we have when we are covering the contingent valuation method, we have seen that the willingness to pay will vary, the mean willingness to pay will vary from minus infinity to infinity. However, we take the conditional value because the willingness to pay cannot be negative. So it will be in the positive direction. So the right answer will be minus infinity to infinity in this case. Okay. Now, in the second question, we are asked which of the following can be considered as limitation of limitations of open-ended referendum, right? So, in the limitations of open-ended referendum, we have set the hypothetical bias, and in the strategic bias problem, we have discussed the warm glow effect as well as free riding problem. So we have also discussed the embeddedness, right? Embeddedness is that the individual is not the sorry embeddedness is when the uh, difference in when the uh, individual is not able to make the difference between a part as well as a whole, or between one or two or more uh, environmental quality increment. So that is all the problem of open-ended referendum. So therefore, the option of all of the above is correct in the second case. Okay. So in the first case, we have set the expected value of willingness to pay. In the second question, we are asked the limitations of open-ended referendum. And in the third question, now we are asked individuals' willingness to pay for additional consumption of commodity will always decline due to. So for this question, I am expecting answer. I hope that you have solved it also, but if possible, then it would be great if you answer in the chat box. So the third question you are asked that individuals' willingness to pay for additional consumption of commodity will always decline. So why this is so? Any Okay, so this is because of the diminishing marginal utility, right? So the right answer will be diminishing marginal utility. Now, we have also learned about the risk aversion. So the risk aversion is represented by the concave value function, right? And the risk in this. So the risk aversion is shown by the concave value function and risk loving is shown by convex value function. So here we are asked about the risk aversion, which is represented by concave value function. Okay, then we have endowment effect, which is known as individual prefer to retain the goods and services which is already in the possession rather than the getting same goods and services from someone else. So that is what we have defined endowment effect as. So if you already have certain goods and services, the rather than acquiring new one, you will always try to retain the goods and services. So that is known as endowment effect. Then we are asked reveal preference method are dash because they involve actual behavior and dash because they infer a value rather than estimate it directly. So, reveal preference approaches are observable, however, they are indirect. So, therefore, the correct answer is observable and indirect because we are estimating value from some other markets of some other goods and products. Therefore, it is indirect and it is observable because of the premium which is being paid for additional environmental qualities. So that is why the observable and indirect are the correct answer. Now we are asked what is the key element of CVM. So in contingent valuation method, first we design the questionnaire, we construct the hypothetical market, we assume the value of AI, that is the price, which is willingness to pay or willingness to accept for the change in environmental quality. Then we collect the bids and there is method of valuation. So the all of the above option is right for the steps or which for the elements of CVM methods. And then in the eighth question, we are asked the hedonic pricing approach can be used to place a value on pollution damage in urban setting. So why? Because so the right answer is holding all else equal, property value tends to be lower in polluted neighborhoods, right? So in the urban place, let's say that there is two places, one is in the green area and one is in the polluted place. The when the other quality of the building are same, then the price of house at polluted neighbor have lesser value, right? So that is the answer. Next is in the reveal preference approach. In the reveal preference method, um, estimates the value of environmental goods and service which has been experienced. Next one is estimates the value of environmental goods and services which had not been experienced. And third one is based on observed behavior. And then fourth one is based on observed behavior of individuals, right? So the right answer here is that both A and C are correct. So um, in the reveal preference approach, what we do is uh, the value of environmental goods and services are derived from some other markets. So it is being experienced, and C is that it's based on observable behavior of individuals. So both A and C are correct in the option. And question number 10 we have already solved. So that is it for the question answer part. Now we will move again to few more topics. So if you have any question in the quiz or in the practice question, then you can ask me also. So now we are moving towards the we have already discussed the choice experiment and uh, reveal preference approach, right? So now we will move choice experiment and then limitations of choice experiment. That is that too less of attributes will lead to the improper definition of goods or services. Too much of attributes will lead to the confusion, which will lead to the heuristic responses. And therefore, there is a requirement of optimality. So this is what we have learned. And now, in the reveal preference approach, what we do? So, in the reveal preference approach, we have hedonic pricing and travel cost method. Hedonic pricing is based on based on related market. Let's say that the housing market, right? So, how for a house in a green area and polluted area, the price of house in the green area is higher than the uh, price of house at polluted area. So this premium money which is paid shows the consumer's preference to clean environment. So that is what we have derived. Now, in the reveal preference approach, uh, hedonic pricing is based on characteristics value of theory of value, where Pi is the price of house, Si is the size specific factors, Ni is the neighborhood specific factor, EI is the environmental factors. Okay, so now the price of a house, let's say, is dependent on uh, site specific factor Si1 to Sin. So these are all site specific factors. Okay, now it is also dependent on neighborhood specific factors Ni1 to Nik. So site specific factor will be will be the attributes of its own house or its own quality. Neighborhood specific factor will be, let's say, near towards the metro or near towards certain mall or accessibility of various products. So that can be in the neighborhood specific factors. In the first one is site specific factor, second one is neighborhood specific factor, and third one is environmental factors. So environmental factors can be air quality, greenery, or it can be access to clean water, and so on and so forth. So these are all environmental quality, and UI is representing the error term. Okay, so now if you regress price, so you have the data of price, you have the data of various attributes of house, Si1, Si2, and so on and so forth. Now when you regress, you get the value of beta q, right? Let's say that beta q, here beta q E1 EI1, where EI1 is my air quality, then beta q will represent it for 1% change in air quality. For 1% change in air quality, what is the change in housing price? That is given by beta q. So the change in housing price will be beta q percent for 1% change in air quality, right? So we are keeping other factors as constant, and then we are calculating beta q. So we are giving the representation of beta. So how the coefficients represent. So first we will collect all the data in the, let's say that there is 1,000 houses in a specific area. So first area 1, area 2, so on and so forth, right? So for each area we are collecting the data of all the all the parameters, price of house, site specific data, neighborhood specific data. So we have all these parameters from SI1 to SIN, NI1 to NIN, so NIK, and then EI1 to EIR, right? So all these parameters are collected and then we regress it, right? So from regression, what we get is the coefficient value, and this coefficient value gives the marginal change in the price of house with change in the environmental quality, right? So this is how it is being represented. Now, let's say that what we do in hedonic pricing, we collect the information on house price for different locations, site specific factors, neighborhood specific factors, and environmental factors. We apply a regression model and then we estimate the value of beta coefficient. Okay, so then what it is like? Let's say that EI and PI. So EI, from EI1 to EI2, let's say that for better environment from EI1 to EI2, what is the premium delta PI a person is willing to pay? So this delta PI by delta EI is the price premium for better environment. So that is how we are uh, calculating the economic value of environment. So in this method, we are finding the change in the price of housing with change in the environmental quality. So now we are discussing the limitations of hedonic pricing. So the limitations of hedonic pricing includes, first one is hedonic price can capture hedonic price can capture only a part of total value of environment. So here what we assume is that environmental quality improves, only the house owners are going to benefit, right? So what we are saying is that what is the willingness to pay, extra willingness to pay for better environmental quality? That is what we are calculating. However, there are many people, many individuals who do not have house there but may also benefit, right? So their willingness to pay is not captured. Only the benefit of individuals having house in the cleaner environment is compared. However, maybe those people who are not there might also be benefited, and they also might have willingness to pay for the cleaner environment. So this willingness to pay is not uh, included in the hedonic price model. So that is one of the first biggest limitation. Then the second one is that we assume that housing market is at equilibrium, which implies that the consumer can easily locate a house based on the marginal cost and marginal benefit. So we are equating MB, marginal benefit, is equals to marginal cost. Then based on this equilibrium condition, the consumer will choose the best house based on their marginal benefit and marginal cost curve, right? So demand and price is always theoretically derived from in equilibrium condition. However, many a times, because of information asymmetry, because of various transition costs involved, this might not be the case, right? So the optimal pricing and optimal house uh, is not derived. So that might be the second limitation of this hedonic pricing theory, that housing market might not be in equilibrium condition. Okay. Now, third limitation is that we assume that both the consumer and seller of the house have perfect information which in reality may not be the case. Let's say that we are comparing area 1 and area 2, right? So if a person buys area house in area B, which is more polluted compared to area A. So if I have to pay, let's say that 4,700 per square feet, and for B 4,900 per square feet, then if I'm staying at area B, is it indirectly means that I'm not willing to pay this 200 rupees, right? I'm not willing to pay this 200 rupees for cleaner environment in area A. However, maybe because I don't have information about the price at area A, because of information asymmetry, there is the gap. It might not be because of the uh, uh, not because of the uh, that I'm not willing to pay. So it might be because I don't have information about the price in the area A. So in this case, then we can say that the consumer do not have perfect information about the house. So in such cases, then we cannot say that this difference is because of the premium which the person in area A is paying, which the person in area B is not paying, right? So this is not the case when there is information asymmetry. So now in the fourth point, we say that in hedonic pricing mechanism, expectations about future price is not including. So let's say that I buy in area A, seeing that there might be a IT hub. There might be a IT hub in the area in another 10 years, let's say. Then my price of this house will increase, right? So by looking into long-term investment, I might buy the area, buy the house, right? So in area B, which is more polluted, and area A, I choose area A because there is more future in scope, right? So in hedonic pricing mechanism, expectation about future price is not considered. So here the extra money is always considered as premium money. However, in the premium money paid, expectation about future rises are also included, right? However, hedonic pricing model cannot include the expectation about future price rises. So that is one of the limitation on hedonic pricing. So now we will move towards the travel cost method. I will take another 10 to 15 minutes and then we will end the session. Okay, so in a reveal preference approach, the first method is travel cost method. So in the travel cost method, what we do is that the amount of money spent to travel to enjoy the natural beauty of a place uh, shows the consumer's preference for cleaner environment. So the expenditure which is incurred to visit a particular site, which is used as proxy for the value of natural site. So by visiting the place, preference for the environment is revealed. So in the however, the limitations of travel cost method is that um, we will only include the use value, but it does not capture the non-use values such as option value, existence value, and bequest value. So while in travel cost method can capture only used value, stated preference approach can capture both used and non-used value. Okay, so this is the limitation of reveal preference approach, in which only the uh, used value is considered. The non-used value cannot be considered in this case. However, in stated preference approach, both the used and non-used value are considered. Okay. Now, what are the steps for a travel cost method calculation? So, first we will ask certain questions, that how many visits or trip you made to this place in the last 1 year. Then we will note the VI, which will be number of trips individual I has done, then how far you have traveled, then how do you do, or what do you do, or what is your monthly income, and then the family size, and then the while visiting place A, are you planning to visit any other competing sites nearby? So if a person is visiting other sites also, then the money which is incurred for traveling is not only for the uh, a certain place, right? So in this case, then the whole valuation of environment is not done through the travel cost. So what we do is, here we have assumed that number of visits on the site is inversely proportional to cost per trip. So let's say that the cost of visit for first person is 100 rupees, then it will visit, let's say, one time. And if it is only 50, let's say 80 rupees or something, then it will visit two times. So they lower the price or per trip, higher will be the number of visits. So based on cost and number of visits, we are trying to draw this model. So in the model, what we are finding is that log of Vi is function of alpha times minus beta Ci. So Vi is the number of trip ith visitor made in 12 months, and Ci is cost per trip. So now we estimate the function based on a regression model, and then the economic value of site is equal to consumer surplus, which is equal to area under the demand curve. This area under the demand curve can be known as the economic value of the site. So this is how travel cost method is uh, solved. Okay. So now we have a few more slides. Okay, so now we are asked that why do we need to estimate the value of site? So the value of any environmental good and services is estimated so as to do the cost benefit analysis. Let's say that there is a highway which is to be made through a forest. So first we will find the value of this forest, and we will find the benefit of converting the forest into the highway, and then we will find the loss because of the conversion. So the cost benefit analysis of natural site is done by evaluation of the sites. Any environmental goods and services might have number of competing demands. So let's say that the natural site is converted into five-story building or shopping mall. Then we need to know the cost and benefits of building, such as converting natural site into other developmental activities. Then we will do cost benefit analysis. So the value which we obtain is total consumer surplus, and we have to compare it with the benefit of shopping mall. Then we will think whether it is a good choice or not, right? So this is how we compare the value of site with the um, benefit of applying uh, or building a shopping mall. So Therefore, the valuation is needed. So this valuation is done by various approaches which we have discussed from the start to the end. So from after valuation, we do the cost benefit analysis, and then we will choose which option is better. Now, some important points to be noted in interval cost method. First one is the OLS cannot be least square method cannot be applied like linear regression due to limited information in the dependent variable, as information is collected from people who are only visited. So those people who do not visit might also want to come, but because their budget is little lower than the required, they are not able to come, right? So in these cases, the potential visitors as well as those who are not able to come because of budget constraints are not considered, so the dependent variable information is limited. So in this case, we use Tobit model, where we consider a latent variable vi star, which is function of alpha times alpha minus beta times Ci plus Ei. So Ci is cost per trip and Vi is number of visits, right? So Vi star is latent variable, and uh, Vi function is given by Vi star for Vi more than 0 and 0 for otherwise. And this latent variable gives the potential visits, or also gives the budget constraints of those individuals who are not able to come because of lesser amount of money that they have, right? So therefore this Tobit model is used, and the time value of money is calculated for employed person. However, it is difficult to calculate for the unemployed person. Then, if a person is coming for multi-purpose trip, let's say that there is a meeting somewhere nearby and then they come, then we have to identify the common cost and then develop a formula to apportion the cost which is specifically incurred to visit the site. So by apportioning or by dividing the cost uh, of visit to the other purpose and then the visit to the specific site, we will try to develop a formula and find the value of travel cost. And in the case of multiple trip, then we have to develop a random utility model to estimate the probability of visiting any particular site. So if the probability dependent only on the site specific feature, apply conditional logic model, and if the probability depends also on the individual's information, then we have to apply for the nested or mixed logic model. So with this, I will end today's session. So in the next session, we will cover the production function approach, and then we will move towards the week 10 session. So thank you for joining. I will stop presenting, and if you have any question, then you can ask. Otherwise, we will end the meeting.